Okay, yesterday we looked at writing the equation of trig graphs based on the graph itself. So today what we're going to do is we're going to look at different kinds of functions rather than just sine and cosine and tangent curves. We're going to look at different kinds of functions, and we're going to get the equations of those functions using the graphing calculator. Not all bivariate data can be represented by a linear function. We've got many other functions out there, including curves that we've seen already this year. So the first one we saw this year was an exponential curve. Remember, exponentials tend to grow very quickly or decay very quickly. An exponential curve does not pass through the origin. The y-intercept is positive, and your y values are always greater than 0. So if I was looking at a scatter plot of something that looked like an exponential function, you would see the exponential curve again tending to increase or decrease rapidly. In a log function, a log curve does not pass through 0, 0 as well. Its y-intercept can be positive or negative, but his x values always have to be greater than 0. So a log curve tends to rise or decay, and again, these are examples of log functions. And then finally, a power function is another curve we can look at. Power function is similar to an exponential function, but in a power function, it does pass through the origin. You can have the point 0, 0 in a power function. Okay, so some other specific types of graphs that we have is a quadratic. Remember, a quadratic makes a parabola. So if I were looking at a scatter plot of the data would tend to make a parabolic curve, and we can have a maximum or minimum parabola. Remember, in a quadratic function has an x squared. And then we can have a cubic function which has an x to the third. And the cubic function looks more like a snake as its curve. So what we're going to do is we're going to take data and we're going to find the equations that best model that data of those scatter plots. Lastly, we do have a sinusoidal curve, which is what we've been working on. And a sinusoidal curve can be a sine or cosine curve, but it would model, if we were looking at a scatter plot, it would model a typical sine or cosine curve. So it would tend to have a hill and a valley, or it might just have one big hill or one big valley, depending on what function we're looking at. Now, if we are going to do a sinusoidal regression to get the equation of the sinusoidal function, you must be in radians. Remember, when we're working in trig and we're going to do trig functions in the calculator to graph them, it has to be graphed in radians. Okay, now the next page explains how to make a scatter plot on the graphing calculator, and how to get the regression equation for the scatter plot, and also using residuals to determine the best curve that fits the data. I'm not going to go over these instructions on this video. What I'm going to do is work through it on the graphing calculator on the next couple examples. But if you get stuck, all the directions are there on creating a scatter plot, getting the regression equation, and looking at the residual plots as well. Remember, the residual plots help us to determine which fit is the best for the data that we're given, which type of model we're going to use for the given data. Okay, in example 1, the maximum amount of daylight that hits a spot on Earth is a function of the day of the year. So depending on the day of the year will determine the amount of daylight that hits a certain spot. Taking x equals 0 to be January 1st, daylight in hours was measured for 12 different days. The measurement was the number of possible hours of sun from sunrise to sunset. So day 0 again would be January 1st, and there would be 9 hours of daylight on January 1st. So first what we're going to do is use the calculator to find the best sinusoidal function for this data set. And we're going to round all the parameters to the nearest hundredth. Remember, your calculator should be in radian mode when you're doing a sinusoidal regressions, and there's some little tricky stuff about sinusoidal regressions that I'm going to be talking about in a second. Okay, so if you turn on your graphing calculator, we have to get that data into the graphing calculator. So I'm going to hit the Stat button, and then I'm going to hit Edit. Now, if you have data in L1 and L2, you're going to have to clear that data out. So you would just go up to L1, hit Clear, and then Enter. Don't hit Delete, because Delete will delete the entire list. I'm going to pause the video. When I come back to the video, the data will be filled into L1 and L2. So that's what I want you to do now, is fill the data in for L1 and L2. Okay, so I currently have my data in L1 and L2. Make sure you scroll through the list and make sure you've entered the data in correctly. So you want to make sure the data is in there correctly, because otherwise your decimal values will be off slightly. So now what we're going to do is we're going to hit the Stat button again, and this time we're going to go over to Calculate, and we want to do a regression. And since I was told I wanted to do a sinusoidal regression, I'm going to look for sine regression, which is option C. Hit enter. Now it says iterations, and iterations should already be filled in as 3. And iterations is just how many times we want the graphing calculator to do the math behind the work to get the equation. We don't really have to change the iterations at all. We're going to keep them at 3 right now. Basically, it's changing the amount of time that the calculator spends on its effort to create the equation. X list is L1 and Y list is L2, because that's where my data is. And the period. Now, this data was taken over 1 year's time. So the period is going to be 365, because there's 365 days in a year, and that's what the data was over. Now, where it says store regression equation, what we can do is we can take a look at the scatter plot of the data and then put the equation into the scatter plot so we can see on the scatter plot what the equation looks like. I'm not going to do that right now because we're new to the regression, so I'm just going to go down to Calculate and hit Enter. And there you can see we have y equals a sine bx plus c plus d. That's our equation of the sine curve. And then we have an a, b, c, and d to fill in the values. So remember, it says round all the parameters to the nearest hundredth. So I have to show work. So my work is going to be stat calc sinusoidal regression. I put the day in L1 and I put the daylight hours in L2. My general equation is y equals a sine of bx plus c plus d. And then all I need to do is substitute the values for a, b, c, and d into the equation. And remember, we're rounding to the nearest hundredth. So y equals 3.68 sine of 0.01 x minus 0.87, and then the d value is plus 11.61. All those values came from the a, b, c, and d on the graphing calculator. Okay, part B, it says according to your model. Now the model is the equation. That equation models the scatter plot of the data that I was looking at. So if you want to look at the scatter plot of the data, you're going to go to y equals, you're not going to go to y equals, but you're going to look above y equals where it says stat plot. And you're going to do second stat plot, which is y equals. And we're going to turn our stats on because we're looking at a statistics graph. So we're going to hit enter, and we're going to turn the scatter plot on. Notice it says X list and Y list. That's where the data is in L1 and L2. And instead of pressing the graph button, I'm going to hit zoom. I'm sorry, I'm going to get out of the stat menu. I'm going to hit zoom and go down to zoom stat. And that's a scatter plot of our sinusoidal data. So the scatter plot looks like that, and the model is the equation that represents that scatter plot. So it says, in part B, it says, according to the model, what is the range of the number of days of daylight hours? What is the range of the number of daylight hours, according to the model? So basically what they want to know is from where, what's the minimum amount of daylight hours and what's the maximum amount of daylight hours? Well, remember, that is actually coming from the midline and the amplitude. If I were to look at a scatter plot, if I were to just sketch out that scatter plot that I had, it almost looked like a parabola. So we want to know what is the maximum and what is the minimum. Well, in a sinusoidal graph, we look at the midline first. Remember, the midline is the halfway point. And then from that midline, we can determine the amplitude. And that will give us our minimum and our maximum. So based on our equation, the midline, remember, is how much we went up or down. which is 11.61. So to get the maximum, we're going to take the midline plus the amplitude, which is 3.68, right, because it's the midline plus the amplitude to get to the max, which is 15.29. And to get the minimum, I'm going to look at the midline and subtract the amplitude, and that's going to give me my lowest point, right? Because remember, the amplitude is the distance from the midline to the max or to the min. So the minimum is 7.93. So the range of daylight hours using my model goes from 7.93 to 15.29 hours of daylight. Okay, in part C it says according to your model, so again according to the function, how many days to the nearest day does it take to complete one full cycle of daylight hours? Remember, completing one full cycle is the period. And the period is 2 pi over b, over the frequency. So we want to know how long it takes to complete one full cycle. That's the period. We're looking for the period, how long it takes to complete a cycle, equals 2 pi. Now the frequency comes from the model, which, excuse me, in this point, in this graph we're looking at 0.01. So it's going to be 2 pi over 0.01. And we just cross multiply. 0.01x equals 2 pi. Divide by 0.01. And x is going to be equal to 628.3185, 307. And it wants us to round it to the nearest day, so 628 days to go through one complete sine curve. Okay, in example 2 it says the table gives the file size of a computer program called SuperType over the course of 6 different versions. So I have 6 different versions there and the size of the actual program. Part A says determine the regression equation that is most appropriate. So what they're asking is, am I going to be doing a linear regression? Does it look like a line? Does it look like a parabola? Does it look like a power function? Does it look like a log function? So in order to determine the best equation or the best model to use, I have to look at the scatter plot. So what you're going to do is you're going to pause the video, you're going to put the data in L1 and L2, and then look at the scatter plot. When you come back to the video, I'll have the data in there and I will walk you through how to get to the scatter plot again. Okay, so I have my data in L1 and L2. Now I've already turned on my stat plot, so I went to second y equals. My stat plots are already on, so if you haven't done that yet, you're going to want to put your stat plots on. And then we're going to do zoom stat, because I want to see the scatter plot to determine what kind of function I'm going to be using. Now we got a couple different possibilities here. This one looks like either a power or an exponential function. So I might do a power regression, or I might do an exponential regression, depending on which model best fits the data. Now this is where residuals come in, and you got to think back to 9th grade for residuals. In order to determine which function I'm going to use, which model I'm going to use, I need to check the residual plots. Remember the residuals from 9th grade, we want randomness in the residual plots. So what the residual does is looks at the distance from the model to the actual data value. So it looks at what distance the line of best fit was to the data point that was on the scatter plot. So what we want to do is we want to turn our diagnostics on. So you're going to hit the mode button. And you're going to go down to Stat Diagnostics and turn them on. And then we're going to quit out of there. And the first thing we're going to do is we're going to run the residuals for our exponential regression. So we're going to go to Stat. Oh, I'm sorry. We're going to go to Stat Plot, second y equals. Go to Plot. Make sure your stat plots are on. Then I'm going to hit stat again. I'm going to run the exponential regression. Because in order to look for the residuals, I have to actually run the regression first. So I'm going to run the exponential regression. Data's in L1 and L2. I don't have to store the equation, so I'm not going to worry about that. I'm going to go down to calculate, and I'm going to run the regression equation, or exponential regression. Now what I'm going to do is I'm going to look at the residual plot. So I'm going to go to second y equals, which is stat plots. And instead of having L1 and L2 for your X list and your Y list, your X list is still going to be L2, but you're going to change the Y list. So we're going to change the Y list so that we get residuals. So we're going to hit second stat, and we're going to go down to number 7, residuals. So what we're telling the calculator is use the data in the X column, or X values, and then look at the residuals. Now that residual won't show up unless you've already run the regression. And then we're going to do zoom stat. And there's our residual plot for the exponential regression. Remember, we're looking for randomness around the x-axis. So those scatter plots, or that scatter plot is pretty random around the x-axis. So it looks like exponential might be a good model. But we're going to do the same thing now for the power regression, because remember, we weren't sure if this was exponential or power. So now I'm going to go stat, calculate. This time I'm going to do a power regression. So PWR regression. L1 and L2 is where my data is at. I'm going to calculate the power regression. And now I'm going to look at the residuals for the power regression. So I'm going to go into my stat plots again, second y equals. I've got my data in L1, and I'm going to look at the residuals for the power regression. So do zoom, I gotta quit out of here, do zoom stat. Now, this is a residual plot for the power regression. Now, this one looks more like a curve, and that's not what I want. I want random points around the x-axis. I want them to be scattered, and this has more of a pattern to it, looks kind of like a parabola, which means a power regression is not the right model to use. So based on the residuals, I'm going to go back to that exponential regression. Stat, calc, exponential regression. Data's in L1 and L2. So my work, stat, calc, exponential regression. The equation is y equals a times b raised to the x. And it says I'm rounding all the values to the nearest thousandth, which is 3 decimal places. So 95.699 times 1.596 raised to the x. So looking at the residual plot helps us determine which function we're going to use. Remember, we want random residuals. And remember, if all these calculator steps are difficult for you, then you can always go back to the steps that I have on the second page of the notes. Okay, in example 3, I want you to try to walk through example 3 on your own. A pediatrician has the following table that lists the head circumference for a group of 12 baby girls from the same extended family, and the circumference is given in centimeters. You're going to choose the curve that best fits the data. So you're going to want to you're going to put your data in L1 and L2. You're going to look at the scatter plot, and then you're going to run some residuals based on the scatter plot that you're going to see. And once you run the residuals, you're looking for the most random model. Okay, so you want to think about things like, am I doing does it look like a parabola? Does the scatter plot look like a parabola? Does the scatter plot look like a power function? Does it look like an exponential function? Does it look like a log function? Press pause. When you come back to the video, I'll have the stuff calculated. Okay, now hopefully you've got the data in there and you've looked at your scatter plots. Now I have my data in here. I'm going to look at the scatter plot. So I have to go back to my plots. Now remember, we changed this to residuals when we did it the first time, so we have to change that back to L2 so we can do the scatter plot on L2. So second, number 2 is where you're going to find L2. And then I'm going to do zoom stat to look at the scatter plot. Now that scatter plot looks like it could either be a power function or a log function, so you want to look at the residuals. before we can do that, we have to run both regressions. So I'm going to start with the power regression first. So StatCalc power regression. I'm going to run the regression. And what that does is helps me create the residuals. So I'm going to go back to StatPlot. And instead of looking at the regular scatter plot, I'm going to now look at the residuals. So second, stat, and I'm going to change it to the residuals. And then I'm going to do zoom stat to look at the residual graph. Now those values are pretty scattered about the x-axis, which is good. That was the power function. That's what I want, is random residuals. So now what I'm going to do is try the log function, the log regression. Log regression is ln, reg, natural log, on L1 and L2. So there's my log regression. Now I want to see those residuals as well. So I'm going to go set second y equals. I'm going to look at the residuals for the log regression. So I'm going to do zoom stat to look at the residuals for the log regression. And once again, those are very random around the x-axis. So what I wrote down was we could look at a power or a log regression, but both models have random residuals. So that means that both models are going to be a good fit for this particular data. So I ran the power regression and I ran the log regression, and I got down my equations for both the power and the log, because again, both of those models had random residuals. Notice I showed my work for both types of regressions. Most of the time you will be told what regression model to choose. So remember, you're going to be looking at power regressions, log regressions, sinusoidal regressions. If you're doing a sinusoidal, make sure you're in radian mode. You could be doing quadratic regressions, linear regressions, and most of the time you will be told what model to use. If you're not told, you're going to have to look at the residual graphs to determine which model to use.